we'll look at the calendar right here. And this person is like this. And pop up, here we go. Do go ahead and turn off your screen though. Thank you. Okay, all right, so close, continue, full, blah, 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 blah. We are going to do lesson 5 today, which is great. If you were not here last time when we did lesson 4, you're already behind. Okay, but luckily you're only 1 day behind, and that's not terrible. You should be able to recover from that. But regardless, you need to be working on whatever we're working on in class. Just to be clear, it is not appropriate to be working on work for another class while, like, during instruction. If you're done with the day's work, then that's different. Okay, so we're going to start lesson 5 from the current unit. And we are going to get functions. Okay, functions are, well, we'll watch the quick video and then talk about all the sort of analogies, but they are on the very short list of most important concepts we'll talk about, like a list of 4 or 5 things. They are one of them. We're going to use them every day forever. Okay, and if you were here last time or did the work from last time, you will be able to appreciate how much they make things easier as compared to the tedious repeating of, like, move forward, and so on. Okay, so watch a quick video and then we'll get going. And this is what we're about to do, so do pay attention.
One of the most important concepts in computer science is how to define new commands, how to add your own words to a computer language. Most computer languages have only about 100 words or commands, and really the art and magic is in defining your own new words out of these building blocks. We do this all the time in sports. For example, in basketball, you start by learning how to dribble, how to do a layup, how to rebound. Once you've learned these really basic moves, you learn new moves and put together these building blocks, like a pick and roll or a give and go. And you can then go from there to do more complex plays. And once you learn that play and give it a name, everybody on the team knows how to do it. Similarly, once you've taught a computer how to do an action once using these sequence of commands, you can make up your own name for that action. So it's easy to repeat it later. When you define your own command and give it a name, that's called a function.
There are 2 steps to using functions in JavaScript. First, we need to define our function, and then we need to call it. When you define a new function, you are simply giving a single name to a set of actions you want the computer to perform. To call a function, you just type the name of the function, followed by parentheses. This is actually telling the computer to perform or execute the set of actions you gave a name to. You've already been calling functions when you use the turtle commands. The only difference is that someone else defined them for you. Notice in AppLab, the toolbox now has a tab called Functions. There are 2 blocks in there, one for defining a new function and one for calling a function. Let's make a function that moves the turtle forward twice. We'll call it move twice. Drag a new function block out and type in the name you want to give the function. Now, add the code that you want to run when the function is called. We'll add 2 move forward commands and then run our program. Hey, we defined a function, but nothing happened. The reason is we forgot step 2. We need to call the function. To call the function, we drag out the other block in the Functions tab and add in the name of our function. Now that we have both defined and called our function, the code will actually run and the turtle will move. Notice that if I also call the function before its definition, it still works. It just calls the function twice. Defining a function simply gives a name to a block of code without actually running it. The definition can actually be anywhere in your program. The rest of the code will execute line by line, just as before. Calling a function executes the lines of code inside the function, and afterwards, the program returns to where it left off when the function call was made. The fact that the function definition can be placed anywhere means that your code can get messy and really hard to read. So we typically put our function definitions at the end of our programs to help keep things organized. In JavaScript, we call them functions, but the generic term is procedure. All programming languages have a way to define and use new procedures, and it's just another example of how computer scientists use abstraction to solve problems. Once you have written a procedure or function that you know works as intended, you can call the function as often as you wish, without worrying about the details or problems you had to solve to get it working. And in defining a function to perform a certain task, you've essentially increased the capabilities of the programming language and can now use that function on its own or as a part of even more complex actions. You can also see why it's important to give your function a meaningful and descriptive name. If you called it something like do stuff, it would be unclear what the function was supposed to do and make it hard to use in your own code. By referencing a large and complex block of code by a single name, it makes it much easier to understand what a program is doing by reading the code, and also easier to locate and fix problems or errors.
Go ahead and find your way to the calendar spreadsheet and open up code from there. You don't need to talk to do that. Thank you. Excellent. All right. So lesson 5 looks like this. You should be able to get to it. I'm pretty sure I opened it. And bubble 1 again is all of our vocab. So we talked about abstraction before. Let me put this up on the back. There we go. Okay. We've talked about abstraction before. It's the layer concept, solving one problem and having it work and never having to worry about how it works again, so long as it works. And function is the thing that we just learned about, or that we're going to do. Bubble 2, square 2 is the video. So you can go straight to bubble 3. And when it gets there, will look like this. Okay, so when you get here, we see our goal is to create a new function called turnaround. Okay, so the way we're going to do that is we're going to go to the functions bar. Oh, you know what? I need, give me a second. The functions bar, and I need my drawings. How did that happen? Let's go like that, and I'll go downloads. Arnac, and load up, please. We run in. No, not yet. Active Inspire. Go ahead and start. It will start, I promise. There we go. All right. So we need to, and it's going to cover up, and we'll close this. We need to define a function. Okay. And the first thing we need to do is bring out the function definition. Okay. And we need to name it. Now, you could very easily use the word call. We're going to call it something, but calling it is like calling the play. We'll just say name it, because calling it is like invoking it, is doing it. Okay, so our function name is going to be turnaround. Okay, and what do we want our turnaround function to do? Well, we want it to do whatever this is doing. So 2 lefts and a forward. So left, left, forward. And if we hit run now, nothing's going to happen because we didn't call the function. So in the functions toolbar, we need to bring out the function call, or call a function block, and we need to put the name of our function in there. And now it will do what we want it to do. Okay. In the video, they talked about keeping code organized, and I will be demonstrating organized code just for your own sake, not for OCD reasons, but for your own convenience. But right now, like, we only have a handful of lines of code, so it's not really likely to get messy. What's up? yeah, we are going to put function definitions at the bottom because the idea is that once you define a function, once you create your tool, you never really need to worry about what's going on. You can just use it. Yeah, I mean, it's also personal preference. The function definition can go anywhere in the program, which is why we usually put it towards the bottom just to keep it out of the way. But for now, this is all we need to do is define a function called turnaround that is a left, left, and a forward, and then call it once. Okay, and if you hit run, it should work, and we can go on to the next one. It should let you, yes, unless I misread something. Okay, and bubble 4. Bubble 4. What time are we done? We got to keep moving. Okay, so bubble 4, our goal is to use a turnaround function. Where is this one? And okay, so we get here and we already have a function called turnaround created, and our goal is to use the turnaround function as a way of creating this more easily. Okay, so there's a couple ways to do this. We could use turnaround just like, okay, well, first of all, here's a great tip for AppLab. If you switch it into text and add some lines, some empty lines, when you go back to blocks, you will get white space blocks. White space is the space in between code, and having white space to define or to show, just to keep things organized, helps a lot. Okay, so we could do a move forward, a turnaround call, and another move forward, and that would do, well, let's slow it a little bit down so you can see what's going on. It's a move forward and a turnaround and another move forward. But we are going to do this pattern for all 4 of the arms of this cross. So we know all 4 of them are going to be move forward, double left, and move forward. Now when we call turnaround, each time we call turnaround, it does all of those things. So we can just call turnaround again, and it should do that. Then we could just throw a left turn in there and call turnaround twice more. There you go. And then a right turn, which we don't have turn right yet. We could write that function, and we will have it later, but to make it back to the original, it requires a triple left. And that is part of the challenge, is to get it back to the beginning. Okay, so the key is we've solved the way of making one of these branches, a forward, a double left, and another forward. And now that we have that, we can use it as much as we need. Okay, so that is it for bubble 4. You can finish it and go on. Gabe, you working on this?
Yeah.
Okay. All right. So we get to bubble 7. What do you get when you get here? You have, let's just restart. Okay. So anytime, quiet for a second, please. Anytime you see a symbol above your workspace, what period is this? First period I'm looking at. Weird. Okay, so anytime you see this symbol next to workspace, it lets you know that the stuff you do in this workspace will be continued on other bubbles, which is fine, except it means when you get to the other ones, you're not going to want to do version history start over. because it's going to start over the entire workspace, starting at whatever bubble you started at. Okay, so we get here and we need to, we're going to write a function that is the equivalent of a right turn. And then that way we never have to do the triple left again. Okay, so we know right turn's the same as triple left. And I'm going to get some white space here just by going. Okay, so now we have our right turn function that we can use anytime we want to turn right. Okay, and we never have to worry about it again. Okay, then use this function to draw some code to draw a rectangle. Okay, we want it to return to the same spot. And here we have a rectangle that is 2 units of forward tall and 1 unit of forward wide. So starting from the beginning, we're going to go forward, forward, and turn right. Or actually, the function is called right. We can't call it turn right because there's a turn right built in somewhere. But forward, forward, right, and a lot of these turtle things, just run it and see what happens. Okay, so it gets me to there. I need another forward and right. Okay, and that's halfway. Let's just do the whole thing again. There you go. Forward, forward, right, forward, right, forward, forward, right, forward, right. And there you go. Okay. The code should look like that. I'm not going to take points off if you don't use white space blocks between function definitions, but I mean, it just is a lot easier to read, especially this is a great time to start good habits. All right. So there we go. We have some program code that will draw a rectangle. And we're going to use that in a second. Okay, bubble 6 is another information page explaining abstraction, but we've talked about abstraction with the internet. Here in programming, low-level functions that are used in other functions is an excellent example of abstraction. Okay, function definitions will use function calls inside them. They will reference or call to other functions. And you'll see how they work together here shortly. Okay, so bubble 7. Bubble 7 keeps your code from bubble 5. And is this on? Please be on. Is it working? Shoot. If this is let's hope it's recording. Okay, so you get here and let's go full screen as always. Okay, so this is the code we had a second ago, or my code from a second ago, and it still draws a rectangle. But what we want to do is put this entire thing inside its own function definition. That way we can just call draw rectangle as much as we want. So I'm going to bring out another definition block, and then I'm going to highlight all the stuff I have from that drew the rectangle the first time and put that inside of there. And let's name this function draw rectangle. And I wonder if it makes you call it rectangle. You can name it whatever. When in doubt, let's just follow code to make it less confusing possibly. Okay, so now we have everything that we knew before draws a rectangle. We put it in a function called draw rectangle. We can call it as much as we want. We don't need to repeat that code. Okay, and how would you want to do it? Well, maybe a turn left and a move forward, and then we could do this. It's gonna draw something. Maybe not that. Let's get rid of the forwards. Make something look less like a swastika. Okay. Yeah, there we go. Okay, so we have a function that will draw a rectangle as much as we want, and we don't need to copy this code anymore. We just have a tool that draws a rectangle, which I forgot to bring it up. the analogy I always use is that a function is like a play in a playbook. The definition, it's 2 steps to call a play for, I don't know, pick a sport, football, whatever. First, you have to draw up the play and put it in the playbook. That is our function definition. Then once it's in the playbook, you have to call the play during the game. Both those things need to happen, otherwise it's not going to work. Okay? And the function definition, the play in the playbook, doesn't really matter where it is once it's written. It can be out of the way. It's when and how you call the function that is affecting things. Okay, so we have draw rectangle function, and this is your first abstraction in programming, probably, where we have this function right. The right turn function is called inside of the draw rectangle function. We have solved the right turn function, or we've solved the right turn problem, and we never have to worry about it again. We can just use it over and over again. Okay, so let's go on to bubble 8. Oh, we got to crush this. We got to move faster. I don't know if we're going to finish this today, which is a shame. Okay, so we got 10 minutes. We can do it. It's distracting. Thank you. Okay, so here we are going to draw or write a program code that will create this shape that we'll call a diamond, even though it's as good a name as anything for it. And the way we're going to do it is with bottom-up problem solving. Bottom-up problem solving means finding the smallest component, the smallest portion of the problem, solving that, and then using that solution to solve the next one, the next level of the problem, and then using that solution to solve, however many layers, as opposed to top down, where you define the problem like at its highest level, at like the full problem, and then break it into components and break that into components. So it's breaking it down or building it up. Either is fine. People have mentalities that do things differently, so it's fine. Okay, so it's going to be 3 bubbles or 3 levels, 3 bubbles. And our first goal is to write a function that will draw a single step. We already have the turn right function. We just needed to find draw step. And draw step needs to do what this thing is doing, which is a move forward, a turn left, another forward, and then we can use our turn right function. And I'm going to make some, oh, that was weird. And if we call draw step, it should do exactly one of those. Okay, so that is it for bubble 8. As long as you have a function that will draw a single step, you're good to go. All right, and I'm going to fly through this just to get it all on a single replay, hopefully. And I'll answer questions shortly. All right, so we have a function that will draw a single step, but we want to draw one, or we want to write a function that will draw the entire side, which looks like that, a quarter of the final diamond. So it's going to be a new function. We'll make a new function called draw side. So we need a new function definition. We will name it draw side. And draw side is going to be draw step 3 times. Okay, so here's draw step once. Here's draw step a second time. Here's draw step a third time. But because this draw side, we're trying to set this up so that we can call it 4 times in a row. We need the function to end with an extra move forward and an extra turn right, so that when the function is finished running, it's over here pointing east, and then it will do the second side. And when that's done, it'll be over here pointing that way. And then that way, the point is that it sets up ready for the next function. Okay, so draw side is going to be draw step thrice, and then an extra move forward and an extra turn right. And we hit run and nothing happens because I haven't called a draw side. We need to invoke draw side. And we hit run and there we go. We have one side done with that extra tail pointing east. And that is it for bubble 9. And bubble 10 is where we put it all together. We have a function that will draw a side perfectly. We just need to run it 4 times. So we are going to make a new function definition and call it draw diamond. And draw diamond is going to be just draw side 4 times. And we just need to call draw diamond. Okay, and now we hit run and it should do the entire thing. And that is significantly faster than just doing, move forward, left, move forward, triple left, move forward, left, move forward, triple left, move forward. It would be like 80 to 90 lines of code to do it. And here, significantly less, but also much more scalable. If we wanted to do this, add aspects to it. Okay, and let's check. Let's do some, or at least introduce the checks for understandings. And let's go boom, boom, boom. And that, and like that. And here we go. Checks for understanding. Okay, bubble 11, choose 2 statements that are true about functions. Please be quieter. Thank you. I'm not going to read all the options. We've talked. Yeah, show me you were listening. Okay, choose one that is not true about functions. Okay, bubble 13, in your own words, explain at least one reason why programming languages have functions. Include examples of something you did in this lesson that demonstrates the reason you describe. And the last one, in this lesson, we talked about how to build up solutions to larger programming problems with functions. Plan the code you would use to draw the image shown at the right, which in the future we're going to call Snowflake. I mean, it's as good a design name for anything. Describe each of the functions you would create. You don't need to write out the whole code, just a brief description of what they would do. Okay, so in this, I would probably, just to get you started, I would say, what's the smallest component of this? Probably one of these branches or arms. So I'd probably have a function called draw arm. And then a bunch of arms together makes like a cross maybe. Like that. And at least one more to make the whole thing. Okay, you can write it out in sort of pseudocode, program code type of thing, or you can do it in like sentence form. Draw arm will make one of the blah, 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 blah. Okay, so there's that. And there you go, lesson 5. Excellent. I got, I think, 3 more minutes in class. Get it done.